Welcome to this video. In this video we are going to be learning how to solve second order homogeneous differential equations where we have only a complex root with imaginary parts. So this is the case of complex roots with imaginary parts. Now to solve this particular problem you have to consider the what characteristic equation. So you're considering the characteristic equation, and the characteristic equation is going to be, let's say we use the variable s, we have s squared and plus 9 equal to 0. Remember, you replace every y prime prime with what? S squared. You replace every y prime with s, and you replace every y with 1. So this is a short way of getting your characteristic equation. Now if you want to understand the theory of how I derived the form of the characteristic equation, watch the first video on introduction of second order differential equations where I laid the background for characteristic equation derivation. But this is just a short trick to save yourself a lot of time, especially when you're dealing with an examination where you have to look for different options, okay, not basically theory. You can also use this one in theory, depends on your rapport with your teacher, but to be good you actually derive the characteristic equation from first principles. That is when you're solving a theoretical problem, and you can do that by watching the first video that I gave on second order differential equation. Check my playlist and you see it there. So this is what you arrive at as your characteristic equation, and when you solve this characteristic equation you're going to get what? S is square is equal to minus 9, and s is equal to plus or minus the square root of negative 9. This is plus or minus j root 9, and this is equal to plus or minus j3. Okay, so this is imaginary, so s is equal to plus or minus j3, and j is what? An imaginary value, or some people use I, so whatever you want to work with, it's okay. So I like using j. We in electrical electronic engineering, we like using j. Then mathematics, they use I. So whichever one you love using, no problem, you could stick to it. Now that you've gotten only an imaginary part, remember that from the first video, recall that for s equal to plus or minus j omega, for instance, where omega is the complex part, whenever you solve your characteristic equation and you get this particular value, then your solution y is going to be what? Is going to be is sinusoidal oscillation, which is represented by c1 cos omega t plus c2 sine omega t. So this is the general solution anytime you have complex roots with only imaginary parts, no real parts. So the real part is actually given to an exponential term, and the imaginary part is given as the frequency parameter of your trigonometric terms. Okay, so what you just need to do for this particular problem to round up is that y is equal to, we have c1 cos 3t plus c2 sine 3t. So of course in this problem we are assuming that y is function of time. So if y is a function of s, x or displacement, you have y is equal to c1 cos 3x plus c2 sine 3x. Is that okay? So this is how you're going to be expressing your solutions to problems that have only a complex part, where the characteristic equation, after solving it, gives you only complex roots. Okay, you don't have a real part, but you just have only complex roots. So let's take another problem, and that will be it for this particular lecture. Okay guys, in problem 2 we are looking at y prime prime plus y equal to 0. So we want to assume that y is a function of t, and we want to get the solution. So the characteristic equation is, what is it going to be? Thank you very much. We're going to have, let's say we use m, we're going to have m squared and plus 1 equal to 0. Okay, replacing y prime prime with m, and replacing y prime prime with m squared, replacing y prime with m, and replacing y itself with 1. So that is how we got the characteristic equation. This is the short way of getting it. Then when you solve this, you're going to get m squared is equal to -1, m is equal to plus or minus the square root of -1, and m is actually plus or minus j itself. The square root of -1 is the imaginary value, which is I or j, whichever one you want to use. So this means that y is going to be, and of course j has a coefficient of 1 which you cannot see. So since this is only an imaginary part, we'll have c1 cos t, that's cos 1t, plus c2 sine 1t in this case. So this is the solution for this differential equation. So this is about complex roots having only imaginary parts. I hope you learned and I hope you understood. Don't forget to share, like, subscribe, hit the notification to stay updated, and I'll see you in another video.